walk away learning something about the brain. So as a human and as an educator, I hope that you understand the importance of neuroscience. And lastly, I hope that I can give you an invitation to collaborate with Bright Light Neuro. So we will do this in 4 parts. The first part, I'm going to walk you through the journey of how Bright Light Neuro got started. And then I'll give you an overview of why neuroscience and why now. Next, we will walk through the 4 lessons. So of Unit 1, Brain Basics, I'll walk you through each of those. And after each lesson, I'll give you time to ask questions, make sure that you understand it before I move on to the next lesson. And then finally, I'll invite you to work with us. There'll be a Google form at the end that you can give feedback, but you can also give your name and email if you are interested in working with us in the future. So to get started, there's baby Emma. Growing up, I hated school, which is ironic considering I'm up here as an educator today trying to talk to you about education. I loved lunch, I loved recess, I loved passing period, but I didn't like the school part. And I was smart enough to know how to get by. I knew that if I did really well, that no one would know that I'm not doing much. And so my mom always said that she never remembered me bringing my backpack home, which is true. I did as little as possible and still did well. And it was almost like I had this little secret all the way through education. I ended up going to Purdue, and I studied elementary education, and I love it because I love kids and I love people. And I had some really great opportunities there. I taught in Haiti for 3 months. I taught English there. I studied abroad in Honduras, and I studied abroad in Austria and Germany. And so I had a really great time at Purdue. Everything was going well. And then my senior year rolled around, and for those of you that studied elementary education or education in college, you know that you have to student teach. And I realized people are going to find out my secret. They're going to know that I don't really do much, but I still get by. I had a supervisor, my mentor teacher, and I had a class full of students who counted on me. And so I went to my dad. He has been a neuroscientist for over 35 years now. And I said, I think something's wrong with my brain. I don't think I'm like other people, like I'm not normal. And he later went on to tell me that normal is just a setting on a washing machine. It's not how our brains work. And so he encouraged me to go to the doctor, and I ended up getting diagnosed with ADHD at 20 years old. And it was in the least dramatic way possible, a really life-changing moment for me and really changed the trajectory of everything there on out. I ended up getting on a non-stimulant. Funny enough, my dad helped create that non-stimulant that I ended up taking. And it's a drug where it takes a few weeks to get processed in your bloodstream before you start noticing any behavioral effects. So a few weeks later, I was driving back to Purdue, and the best way I can describe it is my brain used to always feel like a junk drawer. Like it was chaotic, you shoved it shut and hoped that no one saw it. And that drive home, I realized that my brain had transformed into this really nice drawer with little acrylic containers and color-coded and labels. And I had this moment of realization that, is this what I was always supposed to feel like? And so I called my dad, and with a shaky voice, I asked him, is this what everyone's felt like their whole life? And so I end up finishing Purdue. I was really successful student teaching, and I go on to get a job teaching 3rd and 4th grade at Zionsville. I loved it. I loved every moment teaching, and I knew that's what I was meant to do. Don't get me wrong, there were moments that I closed my classroom door and had to put my head down because I didn't know what would happen if I didn't just take a moment to myself. It was chaotic at times, but I still loved it. And I realized I had taught all 3 years during the pandemic. And so for those of you that taught during the pandemic, you know that there was a lot of confusion and stress and anxiety around isolation and the virus and unknowings of school closures. And I noticed this in my kids, and I thought, well, why not try and teach them about the brain too? When I realized my own brain, it really helped me understand myself, and I did, and some really cool things happened. This was an assignment where students had to write about the best part of themselves, and a lot of my kids decided to write about their brains. And I love the last sentence of this. It says, most importantly, my brain makes me me. This next picture really gives a good overview of what the class environment was like. And it's not to say that neuroscience was the cause of all of this, but I do think it helped contribute. As an educator, you know that sometimes when you're teaching your kids, you wonder, like, are you really listening to what I'm saying? Are you picking up on what we're doing? And so I used to say a lot of these things when I was teaching about the brain, and then they started telling them to each other and to themselves. Things like inhale, exhale, you've got this. And mistakes help you grow. We had this environment where mistakes weren't something to be ashamed of, but something to be really proud of. And so this next picture is of my student. She's wearing a Columbia sweatshirt. And I applied to Teachers College to study neuroscience and education. It was the only school I applied to because I realized I needed to learn neuroscience better so that more students outside of my classroom could do the same things that we were doing inside my classroom. I applied to school, I got in, and I decided to move to New York. And the next 2 years at Columbia were incredible. I had the opportunity to collaborate with people like Mount Sinai, the Friedman Brain Institute from there. I presented at the Society for Neuroscience. I got to collaborate with people like Hope and work with BrainFacts. And so really great people. Right now, I'm finishing up my thesis on the impact of neuroscience content instruction in the K-6 classroom. And from all of this, starting with myself as a little girl, Bright Light Neuro was born. A really cool full circle moment is my dad and I co-founded it. So it's really neat to have him by my side throughout all of this. And so Bright Light Neuro is an initiative dedicated to simplifying brain science for young learners. And our goal is to empower students to better understand themselves and the world around them through curiosity, creativity, and compassion. Now, I can't talk about Bright Light Neuro without talking about the great people that work with us. It's me and my dad at the front there, and then the rest of our team are just great people. And together, we have over 50 years of experience in education, and this was my main priority. I wanted to make sure that educators were the ones leading this initiative. We have over 45 years experience in neuroscience, and over half of our team members have advanced degrees. They're brilliant people, and they're also just really great humans. So moving on to the second part of the presentation, why neuroscience and why now? So I'm going to walk through some statistics. A few of them are relatively hard to hear, but nonetheless really important. 1 in 5 adults live with mental illness. 1 in 3 adults aged 18 to 25 had a mental illness in the past year. I just graduated from this age group. I'm turning 27 soon, but having just gone through it, it's really obvious that this is a statistic. 1 in 5 adolescents had a major depressive episode in the past year. So if you think about a classroom of 20 students, that's 4 students had a major depressive episode in that year. 1 in 7 Americans aged 12 or older reports having substance use disorder. And 1 in 10 people aged 45 years or older reports having subjective cognitive decline. So that entails issues with memory primarily. And what's really sad about this statistic is less than half of those people consulted their healthcare provider about it. Over 1 in 5 people experience chronic pain, and this costs the US over $550 billion annually. And then nearly 1 in 5 children are diagnosed with a mental, emotional, or behavioral disorder. This number may seem high, but if you think about your own classroom and students that you've worked with, it seems pretty spot on that about 4 or 5 of your students would have a mental, emotional, or behavioral disorder. Now, the next 2 statistics I have, I didn't put on the screen. I didn't feel like a number or my little graphic could really sum up this next part. Suicide is a leading cause of death for children aged 10 through 14. 4 in 10 high schoolers contemplate suicide. That's almost half of the high school population. And 1 in 10 high schoolers attempt suicide. So while these statistics are really hard to hear, they're really important to think about. And so the brain is at the core of our being. It's everything we think, do, and feel. So everything that's on the screen is possible because of the brain. And so we go back to this question, well, why neuroscience? Yes, we see that it's important. We see that it's everything that we're able to do. And so I want you to think about this metaphorical comparison. If you were an architect or a builder, you would most likely have to become an expert on things like your materials, the tools that you use, and then how to make those measurements possible. If you were a chef, you would have to become an expert on ingredients and knowing what to order, the tools in the kitchen, and then how to combine those ingredients to make something good. And so we're not all architects. We're not all chefs, but we are all humans. And in order to understand humans, we have to understand the brain. We have to understand development from prenatal until all the way of being elderly. We have to understand how genetics and experience shape our brain. And we have to understand the systems in our brain when they go well, and our systems in our brain when they don't. And so we now get to a point of, well, why now? And in order to understand that, we have to take a walk through history and understand the field of neuroscience. So, starting with ancient times, the first mention of the brain was 17,000 before Common Era, which is pretty remarkable when you think about it. A little bit later on, Aristotle said that the brain was a radiator to keep the heart from overheating. So we're at least starting to hypothesize, but we're not quite there yet. Galen then said, in 170 Common Era, that the ventricles of the brain were responsible for complex thought and personality and body functions. The ventricles of the brain are the fluid-filled areas of the brain. So again, we're getting closer, but we're not quite there. Fast forward way down the road, we're in the late 20th century, and there have been remarkable advancements in biology, chemistry, physics, psychology, so many different disciplines. But we're beginning to realize there's not a discipline solely dedicated to brain science and the central nervous system. And so it wasn't until 1964 that the first neuroscience department was even created. That was at the University of California, Irvine. And then Society for Neuroscience was created just a few years later in the late 1960s. In the 1970s, we see remarkable advancements in neuroimaging. So the innovation in technology has really helped us figure out what's going on inside the brain, which then leads to the 1990s being declared the decade of the brain. Some of you may remember President Bush saying that we needed to put more energy and resources into neuroscience research and also neuroscience public outreach. Now, that was a great idea, but I don't know if it landed quite like they had planned. When we think about today, we know that a lot of people are interested in their brain. It's becoming a buzzword. There's podcasts about it. There's books about it. People want to understand themselves. But there isn't always accurate science communication. And so this oftentimes leads to people believing something called neuromyths. It's statements that are about the brain, but they're not entirely accurate. So something like we only use 10% of our brain as a neuromyth, or that you can be left-brained or right-brained based on if you were creative or analytical. That's also a neuromyth. And so we really don't have neuroscience available in early education. Now, if you look at what we do have in early education standards, there's some really great things. We've seen that at the NSTA conference. There's a lot of innovation in education right now. So there's biology and chemistry and physics and engineering and ecology and astronomy. And so if a child is interested in engineering and biology, they get that introduction at a really early age, and then that interest and knowledge can continue to grow and develop throughout their K-12 journey. And it's not the same for neuroscience. Students aren't introduced to neuroscience concepts at an early age, and so they're not able to grow and develop in that domain. Now, I want you to think about if neuroscience was introduced at a very young age, and we could foster that interest and knowledge throughout their academic career, what are some things that might happen? Maybe students begin to understand what exactly is happening to a grandparent that is struggling with Alzheimer's disease or subjective cognitive decline. Maybe students would better understand mental health, and they would know that reaching out for support is not a sign of weakness, but a sign of strength. This one's funny to me because one of my colleagues works with high schoolers, and she's a neuroscientist, and they always ask her, I know I'm addicted to my phone, but I want to know more about it. And so I think as adults that can also resonate with us as well, TikTok, Instagram Reels, all of the above. And that changes our brain. And so maybe if people begin to learn more about addiction, especially to technology, we'd be able to make better decisions when using technology. Pain is a signal from your body. And so if people began to understand the neuroscience of pain better, maybe they would understand and reach out for support from a healthcare provider, and we wouldn't have 1 in 5 people experiencing chronic pain. Brain safety is a big one. Our brain is the most incredible organ in our body. And maybe if people began to understand that more, they would take protecting their brain a little more seriously. And then social cognition, we are all wired to be social beings, and understanding that and reaching out for that connection is essential to our survival. And then this classroom, if we can teach students about executive function and how to better their executive function skills and emotion regulation skills, maybe students would have more motivation to succeed in school. And then finally, the neuroscience pipeline. If we can get students introduced to neuroscience at a young age, and they can know how great the field is, maybe we can have more people going into neuroscience research to better the advancements in the field. So, why neuroscience? We're humans. We have to understand the brain. And why now? History has led us to this point, and science expansion has grown so rapidly that the public knowledge has not been able to keep up. But now we can, and we need to understand our brain so that we can create a generation of better humans. So where do we start? And this is where the neuroscience and education point comes in. So the very first thing I think is important is really clear learning objectives. If we want to get neuroscience into the classroom, why? It's the question that answers, so what? Why is this important? What do we want students to walk away with and remember years and years and years down the road? These are the enduring understandings that we want them to always have. And so this is by the understanding by design framework, backwards design, starting with what we want students to know, how we will assess that they know that, what evidence will give us that information, and then we plan the learning activities. And so the next one is grab-and-go lessons for teachers. Neuroscience is complex. It's hard. It's confusing at times. And so we don't want to add something to a teacher's plate that expects a teacher to be able to learn an entire new subject just to teach students about the brain. I personally am most passionate about this topic because teachers don't need something else added to their plate, they just need support. So if we can provide teachers with ready-to-go lessons that they can just pick up, they can click a button and they don't have to think much, and they know their students have really great content, then that's a success. The third point is a negotiated curriculum. I know I talked with a few of you about this yesterday, but it is so important that students, teachers, and scientists are at the drawing table when the curriculum is being created. Students need to bring their experience and their interests to the table, as do teachers and scientists. And so this can't be possible if the teachers and the students that will be getting this curriculum are part of the conversation. And I think this is where we have been lacking for so long. Teachers aren't included, and they need to be. And then finally, it needs to be accurate information. I had talked about neuromyths just a little bit before, but if scientists are not reviewing the process of taking really high complex information and bringing it down to something digestible for students and making sure that that content is still accurate, then we're not doing a service to the students. And so that leads us to Unit 1. And this was a unit we created to really give a foundation of understanding about the brain to students and teachers. And so we did this through 4 lessons. I'm already thinking it needs to be 6, but it's going to change and grow. The first lesson is about what's in our brain and just how many neurons we have. The second lesson is about how we use a really integrated network of neurons, even in simple tasks. The third is that experience and genetics both work really uniquely together, which is what creates and shapes our brains today. And then we need to be critical consumers of neuroscience information. So giving students the skills to consume information about the brain, even when they aren't experts in neuroscience.